So I also want you to write this formula. This is how you calculate a seasonal index. By the way, indices is just the plural of index. So if you want to calculate a single seasonal index, you take the data value, and I'll contextualize this with an example later. You take a data value and divide by the seasonal average. Just write that formula for me. We, of course, know our seasons as winter, spring, autumn, summer, not in that order, but we know those as our seasons. But in the context of general maths, we're not talking about those seasons specifically. They are an example of seasonality. Last term, if you cast your brain way back, I know it's melted in the holidays, but let's unmelt it. Last year, we talked about seasonality as a regular occurring cycle within a year. So every year, say between January and February, we have a very common thing occurring. And then March and April, there's a common theme occurring. And so you've got cycles within a year, that's seasons. So yes, summer, spring, autumn, winter can be examples, and that's the first example we're going to look at. But when I say seasons or seasonal, I don't just mean the weather seasons, just to be clear. You can have months as your seasons. You could have weeks as your seasons. You could have 2 seasons in a year, just the first half and the last half. As long as it's a consistent trend within that period of time, it's a season. So, a few different things that I'll get you to write down, but I'm going to get you to write this down, but later when we come to it. First of all, we're going to look at a few examples of what a seasonal indice is, or seasonal index is, and how to interpret that number. So it's going to be a number close to 1. 1 means it is an average season. That season is close to the average. If it's a number above 1, for example, 1.3, then that means that season performs better on average by 30%. Those numbers after the decimal place. This season, 1.15, performs 15% better than average. This example down here, 0.52, because that's 0.48 below 1, not 0.52 below 1, 0.48 below 1, then that would be 48% lower than average. Okay, so just let that sink in. That's all the seasonal index is telling you. It's on average, that season performs better, worse by certain amounts. Okay. We're going to use the seasonal indexes, or the seasonal indices, to deseasonalize data, which is a fancy mathematical thing you can do, which means I can take, say, ice cream sales, which of course are going to be way bigger in summer and spring and way less in autumn and winter. And I can say, but I want to know, are my staff at my ice cream store actually doing their job in winter? Like, are they actually trying to sell ice cream still? Or are they like going through the motions because it's winter? And I can do that by deseasonalizing, which will basically remove the impact of seasons. And I'm just left with comparable sales amounts. And I can say, well, yes, they're not performing, or actually they're doing quite well in winter. So I'll talk about more of that later. But first we need to be able to calculate seasonal indices, which is the formula you wrote down before. So we'll look at an example. Here is some sales data for summer, autumn, winter, and spring. As you can see, autumn and winter, the colder months in Australia, are performing better. Let's pretend these are in thousands of dollars. So 920,000, 1.08 million, blah, 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 for a big company. They perform way better in winter and autumn, worse in summer and spring. Maybe it's a company that's like Kathmandu, maybe. They sell some winter gear, so probably they sell more in winter and autumn. What we want to look at with this whole concept is what season actually performed better this year. Because pretty much every year, we're going to sell the most in winter. We're a winter clothing company. But maybe, as I mentioned before, maybe my employees aren't doing very well in winter, or maybe in spring they're not doing very well. Or maybe I'm going to try and run an ad campaign in spring to boost summer sales. The only way I can tell if that's actually working is to remove the impact of the seasons, which is the whole point. So in order to calculate, first things first, the seasonal index, we take the actual values and divide them by the seasonal average, which is what you've written down. We have the actual values, but we don't have the seasonal average yet. So step number 1 for calculating a seasonal index. Just going to write seasonal index steps. Step 1, determine the seasonal average. Which just means add up all your numbers and divide by how many seasons you've got. Which is sum of values divided by number of seasons. Yeah, so if you're ready, you've got a calculator with you, unless you're extremely brilliant. Add all 4 together, divide by 4, because we have 4 seasons. Add them together, divide by 4. And write down your answer. Nine, 2, 3. So 923 is the average. So straight away you can look at these values and just straight away realise that summer is basically average, autumn's above average, winter's above average, spring is below average. We knew that anyway, but now we can quantify it by using the seasonal indices. The way we actually calculate the seasonal index itself, that decimal number, is we do, step 2, we do what the formula we wrote down before is. So you don't have to write again if you want, but you can. The actual value divided by the seasonal average. Which this is. This is the seasonal average. So I'll do winter as an example. Sorry if you can't see the board at the bottom there, but I'm doing example for winter. Would be 1241. That's the actual value for winter, divided by 923. Which equals something. 1.35, maybe. What'd you get, Harry?
318. Double check that.
Yeah, do the top one divide bottom one.
Oh, 1.34.
3, 4? Is there any numbers after 4? Well, perfect.
5, 2, 8.
4, 5, 2. Okay, let's just do 3 decimal places as an example. I'm going to do 3 decimal places. 1.345. You know what would be good teaching? If I did it on the TV, what everyone can see. Seasonal index for winter is 1241 divided by 923, which is 1.345. There we go. Can you please go ahead and do that for summer, autumn, and spring for me? Give you a couple of minutes. They're all going to be divided by the same seasonal average, 923. Now, doing this for 1 year is pretty much worthless. The point of doing calculating seasonal indices and hence deseasonalizing data is over a few years worth of data. Because each year there's just going to be variations, just random variations, and we want to see a consistent trend in the seasons and if they're having an impact. So we're going to do this for 2 more years worth of data, or rather you're going to do it for 2 more years worth of data, and therefore we're going to end up having 12 numbers. We're going to have 4 for year 1, 4 for year 2, and 4 for year 3. And finally what we're going to do is then say, I've got 3 seasonal indices for spring. I'm going to average them out and see on average how is spring affecting. Like, is spring above or below average, and by how much? On average. I've used the average word too many times. Let's do an example. But that's how you calculate, 2 steps. Here we go. So we've already done it for the first year, so you don't have to do that again. But you have 2 more years worth of data. Don't get complacent though, Nath. Don't just start using 923 again. That's the seasonal average for the first year. To calculate the seasonal indices for the second year, you need its seasonal average. So you have to do step 1 again, and then step 2. And then for year 3, again, step 1 and step 2. I'm going to give you about 6 minutes to go through with your calculator, calculate the seasonal indices for years 2 and 3. Same thing, but for year 2 and 3. We can straight away, by doing multiple seasons, see how those seasons in particular are tracking year to year. So we can look at winter, for example, and see that that seasonal index is dropping. That doesn't mean that the sales are getting worse, because we can look at the raw numbers and see the sales are getting better, but all the seasons are getting better. So relatively speaking, winter's sales are not getting better compared to the other season. Again though, be careful. It doesn't mean that the salespeople are doing something wrong in winter or something like that. It could just be the fact that spring is increasing relative to the others. Remember when I talked about, say for example, we did a promotional campaign, we ran ads in spring? Maybe that's causing spring to go up. And if spring goes up, something else has to go down because they're all relative to one another. Okay. One thing that I said we're going to write at the start, and I said we'll do it later, is a fact about your seasonal indices, and that the numbers in a single year will always add up to your number of seasons. So we have 4 seasons. So all 4 of these numbers will add up to 4 because we have 4 seasons. All of these 4 will add up to 4. Those will add up to 4. If you have seasons that are monthly, so you have 12 seasons, all of your seasonal indices will add up to 12. So just whatever the number of months, or rather whatever the number of seasons is. And that has to happen because, as I just mentioned, if spring is going up, it's still adding up to 4. So if spring goes up, something else has to go down because they have to balance out at 4. So just because winter's going down does not mean we're doing anything wrong in winter. It actually might be a good thing. It might mean winter sales are staying the same and other seasons are catching up. But how do we tell? We have to investigate further and apply one more skill, the last thing we're going to learn today. It's called deseasonalizing data, which is where we take our seasonal indices and manipulate the actual values, which removes the impact of the seasons, theoretically. So before we get to that process, we need to do one more thing, which is average the 3 seasonal indices you've got. So if you've got these already written, if you don't have these written, in a moment, write them down. But I want you to take these 3 numbers for summer, the 3 seasonal indices, add them together and divide by 3. So we're averaging those 3. Then average those 3, average those 3, and average those 3. You got 2 minutes. So in yellow highlighter at the bottom, that's our average seasonal index for summer, autumn, winter, and spring. And we need to do averages We need to do averages because we're going to apply these values to, not these ones, we're going to apply the average value to all of these. And you'll see what I mean shortly in terms of the actual math. Just want to clarify, the reason we can't just use the individual ones is because these individual ones were calculated just on this. They're based on the average. So if I suddenly do 920 divided by this, which is what I'm going to do, I'm going to get 923. If I do this divided by this, I get 923. If I do this divided by this, I get 923. If I do this divided by this, I get 923. So it's pointless. I just get the average again. However, if I do 920 divided by this, it's not exactly 923. It's the average across all of the summers, which gives me a better picture of what summer is doing to my data. Okay, so as an example, and if you'd like, in fact, I urge you, write a new heading, right under, called Deseasonalizing data. I'm going to put it on the board too. Okay, thank you to those who are copying that down as I went. If you weren't, I'm going to give you 1 minute to just write these couple of things. I recommend it. First of all, deseasonalizing data is the process of removing seasonal variation from a data set. So it's cold in winter, so people buy jackets. I want to know, are my jacket sales across the year being increasing or decreasing without the impact of weather? That's the goal here. The actual process is super simple. We're going to take each data value and divide it by the corresponding average seasonal index, which we'll do as a process. But write that down first. The deseasonalizing process, as advertised, is very straightforward. You just have to connect the right value with the right average seasonal index. So for example, that very first value, year one summer, 920 in sales. We're going to take that value and divide it, because it's a summer value, by the average seasonal index for summer, which we had as 1.034. In this example, they've rounded it to just 2 dp, 1.03. But if you wanted, you could use 1.034. So the actual value divided by the average for summer, which is 1.03, gives us 893. So it's gone down, which means that on average, summer has increased those sales by 27. So 893. One more example so you can do it. I'm going to go randomly to winter year 3, 1450. So in winter year 3, it's going to be 1450 divided by 1.3, which Ty is 1115.3. We'll just go to the nearest whole. So $1,115 in sales. That's no impact of winter. We're not getting free sales because it's cold. I want you to go ahead, your last task for today, calculate all of the deseasonalized values and have a look at the data. To bring it all together and contextualize why you would ever use this. First things first, a lot of you are going to earn a lot more money than me in your lives because, maybe not them, but certainly not them. Some of you will because you're going to start businesses and you're going to profit from that. But as a business owner, you need to be able to investigate your companies, especially their finances. Now, obviously, well, maybe not obviously, but just so you know, you're not going to be doing this by hand based on your own sales. There will be programs and stuff that can do it for you. You, of course, have to do it for your exam in general maths. But understanding why this matters is going to help you down the line. So if we think back to that example I gave where we're at Kathmandu, we realize our spring sales are not good, but we want to improve them. I need 4 minutes, gents. So we're running a promotional campaign, ads on TV or on Instagram or whatever it is. We're advertising Kathmandu. It doesn't really look like it's working based on the raw numbers, right? Yes, those sales are increasing, but they're increasing for every season. So my question becomes, is my program, my advertising campaign actually working? Should I continue to invest money in it? Or am I wasting my time? The only way to check is to deseasonalize and get rid of the impact of the weather or the temperature and get these results. And now we can look and see, yes, they are increasing, but more importantly, they're increasing more than winter, autumn, and summer. Initially, spring, once you removed the impact of the seasons, spring was worse than winter. That's not factoring in that it's colder, that's removing that factor. Spring did worse than winter. So we ran an advertising campaign. Suddenly, in the second year, spring's on par with winter. Seems to be working. In the third year, spring has performed better than winter, probably due to that advertising campaign. So then, as a business owner, or as the CFO of a company or whatever, I might be able to then justify continuing with that sort of advertising campaign. Or I might say, I'm going to run a similar campaign in winter now, so that winter can catch up because it's lagging behind. That's the whole point of deseasonalizing. I can compare these numbers and see that in year 3, summer and spring did better than winter. Not obviously in real sales, because I'm going to sell more in winter no matter what. But by doing the advertising campaign, my sales increased. That's the whole point of deseasonalizing. To summarize, calculate your seasonal indices, average them over multiple years, divide your values by those new seasonal indices.